Welcome guys. So this is another Leetcode solving section called the minimum time visiting all points. Okay, so this problem looks very strange at the first time. But after I figure out the definition, then it's very stupid. Okay, so so basically you have endpoints on a Euclidean plane, and also these points have the integer coefficient, integer coordinates. Okay, so you can move according to the rules. So 1 second you can move vertically, horizontally, or by the diagonally. Okay, you have to visit this point in the same order as that appear in the array. So this is the second is a key point. Okay. So somebody give you 1, 1, 3, 4, 5, minus 1, 0, and then you need to start from here and go layer. So total you will have 7 steps. Okay, so the key point is that since we need to okay, so the key point is that we want to find a minimum from points to points in an array. And then the order must be fixed. Okay, so that means the minimum distance for this array is the minimum distance from the point 1 to point 2 plus the minimum distance from point 2 to point 3. Keep going. Okay, so the key point is that in order to find this, the key point is that we just find this. So we just find find a function which is which is minimum distance from point 1 to point 2, Okay. Okay, so this is our result. Suppose you start from A, B, and C, D, and basically A, B, C, D are integer. Okay, and you can move vertically, or horizontally, vertically, or you just move straight. Okay, so it's very easy to see what is the minimum step. The minimum step should just come from you just try to move vertically. You try to move diagonally and then move vertically, or if this point is here, then you just try to move diagonally and move horizontally. Okay. So what is this? How to compute this? Okay, so it's very easy. We start from AB, and suppose this is TT. This line is this is T. This is T. And suppose this point should be A should be C. Okay, so let me write again. Suppose AB, and this is CD. Okay, so this point the x coordinate is C, and then this is 45 degree. Okay, so you can write down the y component. Okay, so y is the y component. Suppose I spend the t step, then this t step should be equals to just c minus a. So this is just b plus c minus a. Okay, so the distance is just equals to d minus b plus c. D minus b plus c minus a. So this is the distance. D minus b plus c minus a, and plus this t, and then this t just c minus a. So just get d minus b. You just get d minus b. Okay. Suppose your point is here. Then this is similar. Then you just so in this case, the total distance, this distance plus this distance is just equals to d minus b. So it's just difference about it called dy. And then if this point is here, then you can easily show that this is the same as dx. Okay. So what we have proved is that the distance from AB and the CD is just minimum I should say maximum. Sorry, maximum dx and dy. Maximum dx and dy. Okay, so dx just c minus a absolute value. Dy just d minus b absolute value. Okay, so and then we just add the points. Just iterate all of the array. Okay, so we define a maximum just from this. This a and b are the points. So this is dx component. This is the dy component. And then we take absolute value. Then we create a total distance 0, and then we iterate all the points from point I to the point I plus 1, and then we iterate all the array. Okay, so this is the answer. This is the answer. Okay, and yeah, this is the answer. Okay, I will see you guys in the next video, and be sure to subscribe to my channel. Thanks.